The objective of this lesson is to draw open area models to represent one-digit by two-digit multiplication problems. In the previous lesson, students learned how to use arrays with base 10 blocks to solve multiplication problems. In this lesson, students will learn how to use an open area model representing large factors without drawing each individual rod or cube, but by using a blank rectangle. Here's the vocabulary needed for this lesson. An open area model is used when representing large factors. Instead of drawing each individual rod or unit, partial products are written in the rectangles. There is a rectangle represented for each place value. Let's look at a model from our previous lesson. What is the multiplication equation this model represents? How was 23 decomposed? 2 tens and 3 ones. How was the product found? Counting the tens, then counting the ones and adding them together. Can you think of a way to determine how many tens there are without drawing or counting them? What equation could be used to determine the total for the tens and ones? How about multiplying 5 times 20 and 5 times 3, or 100 plus 15, which is 115? To show how this relates to the distributive property, 5 times 23 is equal to 5 times 20 plus 3, which equals 5 times 20 plus 5 times 3, which equals 100 plus 15, totaling 115. Let's set up an open area model for the following problem. Tony works on the weekends at a local cafe to make some additional money. On average, he makes about $43 each evening. How much money can Tony make if he works for 6 evenings? Let's draw our open area model. An open area model is just a blank rectangle. Instead of drawing each rod or unit, just the partial products are written in the open rectangles. So I draw my rectangle and label the row and columns of 6 and 43. Then I decompose 43 into tens and ones. 40 plus 3. Now I draw a vertical line to separate the tens and the ones. Now I do the math. I calculate the tens by multiplying 6 times 40. Then I calculate the ones by multiplying 6 times 3. This reminds me of using the distributive property. 6 times 43 is the same as 6 times 40 plus 3, which equals 6 times 40 plus 6 times 3, which equals 240 plus 18, which equals 258. Let's try another problem using the open area model. Tom decides to buy 3 video games with his birthday money, which cost $55 each. How much money will he spend? Let's draw an open area model for 3 times 55. We start with a rectangle and label the row as 3 and the columns as 55. We decompose 55 into tens and ones, 50 plus 5, and draw a vertical line to separate the tens and ones. Let's do the calculations. 3 times 50 equals 150, and 3 times 5 equals 15. So our answer is 150 plus 15, which equals 165. Tom will spend $165 for his video games. Using the open area model is a key visual representation that can support your child's multiplication understanding and reasoning. It also encourages a visual demonstration of the commutative and distributive properties. In this lesson, we learned to use an open area model to solve one-digit by two-digit multiplication problems. We met this objective by solving word problems using the open area model and using partial products to find our solutions.